All right, so this first one is called the identity function. So fill that in, please. Because sometimes it's referred to with the equation, but sometimes it's referred to with the words. All right, yes, everyone put your phones away, please. Fill in these notes. All right, so on the identity function, whatever you put in is exactly what comes out of it. So when you put in -3, that's also what the y is. So it just matches exactly what the x's are. What do you guys put for your domain? Yeah, all real numbers. What about your range? Good job. All right, where does this graph cross the x-axis? And the y-axis is also. All right, and then this graph, everywhere on the graph, it's increasing. So that's from -infinity to infinity. And this graph is never decreasing. All right, how'd y'all do? Good. Okay. Do you guys know what the next one is called? Absolute value function. All right, and everything you put in to the absolute value function, what comes out is that number's absolute value, which is the distance from 0 on the number line. So you basically are just dropping off any negatives because you can't have negative distances. All right, what did you guys put for the domain? Good. What about the range?
0 to +.
Nice. So in my other class, I noticed a lot of people put all real numbers for the range on this one. It's not. So the lowest point it will ever be is at 0, and then it's going up from there. All right. Your x-intercept and y-intercept are both going to be 0 again. And this one and the next one are the only ones that have increasing and decreasing intervals. So where is this graph increasing? From from 0, when x is 0 to infinity, bless you. And then decreasing everywhere else, which is from -infinity to 0. All right, do you guys remember what the next one is called? Yeah, you spent a lot of time in Algebra 2 talking about quadratic functioning. And everything you put into a quadratic function, the y is going to be what you would get when you square it. So we would just square each one of these numbers. All right, what about the domain? All real numbers. What about the range? We're going to include 0 because we do have a point there, 0, 0, which happens to be our intercepts. All right, and then the increasing is just like it was on the absolute value graph, and so is the decreasing. Y'all doing good? Super geniuses in here? All right, what's this next one called? Cubic. Everything you put into the cubic function is cubed to get the y. Now 27 is not going to fit on this graph. It's okay. Just kind of ignore that point. All right, what about the domain? Yes. What about the range? Yes. So arrow going up and an arrow going down. It's going to be all real numbers. This one's going through 0, 0. Where is this one increasing? Yes, it's increasing everywhere, and it's never decreasing. Y'all good? It always has a positive slope everywhere. If you're moving from left to right, you're going up everywhere. So that's always increasing. All right, and then we have, what is this one called?
Root.
Square root graph or square root function. All right, and I picked these numbers in particular because they're easy to take the square root. You could just do these in your head. So you just find the square root of each of these numbers, and it gives you the y. Now this one stops at 0, 0. That's an endpoint. So what would you say the range is? I'm sorry, the domain?
0 to infinity.
Yeah, and make sure you do a bracket on the 0 because you do get to 0, and then same thing on your range. And the sun goes through 0, 0 again. All right, what'd you guys put for increasing? And decreasing? Never. Okay, this last one is the one you're probably the least familiar with. Do you guys know what it's called?
No.
Okay, it's called the reciprocal function. Do you guys remember what reciprocals are?
Opposite.
Not opposite, you flip it over. So on this one, everything that you put in, what comes out is the reciprocal of it. So what's the reciprocal of -3?
Negative 1/3.
Yeah. So you're just flipping these things over. What about the reciprocal of 0?
0.
Yes. So 0 is 0 over 1. When you flip that over, that's 1 over 0. You cannot have that 0 in the denominator, so it's undefined. If you did this one, your calculator would have told you error. But the reciprocal of 0 is not 0. It's undefined. All right, the reciprocal of 1/3 is 3, and then that's 1/4. Okay, so the domain on this one is kind of different. There's just one number that's not in the domain. So I'm fine with you guys just saying that x does not equal 0. If you wrote out all real numbers except 0, that's fine too. That's perfect. But we're never going to get there. Do you think there's a real number, that you can take the reciprocal of and ever get 0? The reciprocal of 1 is 1. The reciprocal of 0 is undefined. Do you think you can do the reciprocal of a real number and ever get 0? No. So the range is also not equal to 0, but its y is not equal to 0. So if x and y, someone's going to call, if x and y can both not be 0, what do you think that means about your intercepts?
There isn't one.
Exactly. Right, and is this graph ever increasing? No. All right, and then to show where this graph is decreasing, it's decreasing everywhere except when x is 0. So I'm going to show you a couple ways to write that. If you want to write that using interval notation, you would go from -infinity to 0, but not include 0, so do a parenthesis. And then pick back up on the other side of 0 and go to infinity. Or you can just say it's decreasing everywhere except 0. All right. So keep this library of parent functions close by. Like, you'll want it tomorrow. We'll use it to answer questions about these functions.